Welcome to another video on my Raspberry Pi 2, which is connected to network interface and serial interface as well as a band cable, and I'll explain that later if you haven't watched the previous videos yet. It's running Ubuntu Linux as well as the robot operating system, and the network cable is meant for using with virtual network computing. The serial cable, this one, is used for booting it or assistance to booting, and the band cable is meant to connect to this breadboard with some electronics and fischertechnik parts. So this motor with propeller is fischertechnik, a phototransistor being fischertechnik, support is fischertechnik, and this LED as well. Then normal electronics is this one, and all of this, well, except for wiring. Anyway, programmed in C++. The intention is to control everything and to read from when there's light upon, read from here, have this LED burn, and also control whenever this one is running. Does that work yet? Unfortunately, not quite yet. ROS is messaging, so you send messages from one node or from one node to another, and in one case that node isn't working yet as I desire. So last time, to find out whether or not this phototransistor generated a signal that was measurable, not wanting to use the oscilloscope, I put here an LED which definitely worked, as proven by the lamp on my smartphone that really made it blink. So I expected it to get a signal through, and that didn't work. Question: where does that go wrong? So in order to find out, I have to do some tests again. So let's see whatever comes out of that. And if you see my videos before, then you know that I'm also using an Android tablet, and what I found this time is that the whole screen is kind of panable, as you can see. I anyway managed to get the on-screen keyboard, so I can now get stuff going. Let's try to get it running. There's another thing, by the way, before I do that. Here you can see, well, this is of course running Fedora Linux with two Ubuntu desktops, another desktop on the Mac for compiling, but you can see here that there's a lot larger than 1 GB, so it is very much recommended that I do not run it yet, and that I give the ROS clean command. Too few arguments. Okay, why would that be? I don't know. So let's just run the ROS core again. And then I get this. ROS core is already running. Please kill ROS core master. So then yeah, there's ROS core running. So I have to use the kill command for the 5940 No more running. Go. Still over 1 gigabyte. But it does run. So let's have it that way. Then, before doing anything here, let's just fix things. And fix things here, and with fixing is preparing things to run, because that is what ROS is about. And then you will also see what has to be fixed. Alright, so now I have set up everything. This is rather dark, but this one is for the motor and this one is for the red LED. This one. So let's do it. Control. Phototransistor. Fischertechnik LED. Which is this one. And that one is the phototransistor. Then I want the motor to run, so heading this way I say enter. And for the red LED I tap and say enter. Now it would be extremely nice if the red LED would actually do something. But as usual, the wiring is a little bit stubborn. So I have to fix something on the spot. Now it works, including the motor. You can hardly see it, but it really works. In the shadows you can see the movement of the propeller. So that is alright. Next, what I wanted to focus on is this part. Because message 3 is not doing what it should do. Then let's take smartphone again. And then the lamp up, which I have here, and I say OK. Now it works. So will there be any? Well, you can see by this LED here, or can you? Yeah, you can. I move the smartphone a little bit and you see it blink. So yes, it works. With that idea, can I see something over this wire? I should be able to see a signal. How do I see that? Unfortunately, I have to read it from somewhere, which is a port, which is a wiring. So if I read that, I should be able to read the signal anyway. Let's see how I can solve that without software, but just with wiring. Alright, so with the wiring I am looking at the voltage divider. There's no voltage meter, but this LED shows. This is GPIO 15, but it's not pin 15, it is pin 13. So I have to add some text here. Pin 13. Save. So I have to look for something on pin 13 or GPIO 15, whatever is easiest. And that just may be a little bit of a problem, because how do I invoke it? By watching. Okay, open new tab. I need to see in the motor or something else wherever I can switch it, and this is not Python, this is C++, so I may have to do something different. Reading, writing, whatever. How do I control a port? A pin mode, and that is exactly this one. So I am talking about GPIO 15, 24, 25, 12. Okay, but I know it is pin 13. So I have to do something with this. And in this case it is input, so it has to be defined already. And here I see something strange. Input, yeah, correct, pin 13, GPIO 27. Really? So why do I have GPIO 15 here? Okay, but it is an input, that is for sure. It is pin 13. If I count here from 2, 4, 6, 8, 10, 12, 13. So all I do is have to read from that pin. And that's a very good one. Let's find out again. Alright, and according to the information I have, of course, to do pin number 2 is, and then digital read pin number 2. And I will do that in both these callbacks. So the only thing is that I will not see it in here, or most probably I will, by the way, because this is FT-LED. So then I am very curious if this will work, if it will read anything, and what it will show. Using, of course, the flashlight of my smartphone. But first I have to compile it, so let's go to the VNC on the Mac. Alright, so now I'm going to compile, and first I had to kill the process of the fischertechnik LED node, because Ctrl-C didn't work out. Let's compile now. I had to save the source code, of course, first. Let's see whatever happens. Should not take long, it's just a very small thing. Unless I made a coding error, of course, which is always possible. But it's going for FT-LED anyway. Linking, very good. And it's gone. So now it should be running nicely and I should see something on screen. So let's test. And with this stuff compiled correctly, clearly, let's start the node. And using my flashlight, let's see if I can see something. Pin number 2, yes. But I had hoped to see a value. And that I do not. Ah, wait. I make a thinking mistake, because now I don't know which one is which. So I need to change it. This will be then 33, or actually square brackets. And what, I don't know what I am doing here now, but okay, that is better. Square bracket 33, and here it will be square bracket 3. So then I do know which one I'm looking at. But that doesn't mean that there is a difference right now, because no matter what it is, I get no value. So there's still a problem. And I'm running out of time for this video, so that will be next time, finding out if there is really something with this wire. Why there's nothing to read on the port, because that is important. If there's nothing to read on the port, there may be something with this voltage divider, which then is this part of the circuit. If the voltage is too low, you won't read it, and the voltage level, voltage threshold, is 3.3 volts. So that may be a problem, and that I'll probably have to measure them using the oscilloscope. But again, that is then for next time, I'm afraid. So with this app having a little problem, well, the app doesn't have a problem, but the results do. And well, yeah, the Android, both Android by the way, and Mac, well, as I said, some problem with reading probably the voltage. So I may have to replace these resistors, but who knows. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. Always appreciated. And you can also follow me via Instagram and Twitter. Please show your support by making a donation via either PayPal or Wired. And you can also become a patron, and depending on the pledge you make, may have your name mentioned on my website and with my videos. Please also take a look at my website with other projects and lots of other information. For now, this is going to be continued, obviously. Please take a look under this video or for the next segment with other information. And for now, have a nice day and bye bye.